answers here. I kind of underlined, again, my like terms. If I had more than one like term, like on number 2, you can see I did the circles. I underlined the A's. I circled the C's. I don't know if we had any that had 3 sets of like terms like we did in the notes. But just be really careful. Remember those signs, those minus signs are telling you that that term, that coefficient is a negative. So when you use your calculator, you need to make sure that you're typing in a negative there. So the first 4 were just kind of straight across, put those together. Then the last couple had some distributive property. Remember, our distributing is when we have a number outside of parentheses. See, here's my mistake. I made up a 3 somewhere, I don't know. But my B-Day class caught it, so it happens. No shame in making mistakes. But so you want to go in and distribute, which is a multiplication operation. Distribute it to everything in the parentheses. And then these also had like distribute, then combine. So if you see, I kind of have 2 lines of work. And I suggest that you guys, when you do this, and it takes 2 steps like that, show your 2 lines of work. Because if you make a mistake in step 1 like I did, you're going to make a mistake in step 2. Okay? So if you show that, you can check it and see, and you can fix it like I did. Okay? So there's those if y'all want to just check and make sure you're good. And then if you want to, in a little vial or at the end or whatever, you can staple this to your packet, or you can just hold on to this paper. But we just got some paper stuff right now. Do y'all have your Chromebooks? Yeah. Yes. Everybody? Okay. No. You got one? Showing you what's on tap, showing you your calendar. As we're getting into stuff, we got some, actually we have our first check for understanding next class, okay? Our check for understandings are not weighted grades, but there is value in them because we want to know, like, hey, are you getting the lessons or are you not? So if you don't do very well on it, you're probably going to be invited in for tutorials, so that way we can check in and make sure. So today, today's lesson, I'm hoping is not anything that's like brand new to you. I'm hoping, kind of like last time, it's just been a minute, but this looks a little bit familiar from middle school because you should have been able to solve 2-step equations and inequalities in middle school. I know it's been a year, it's been a summer, so that's why we're kind of spending a whole day on it. But I think like the newer stuff that we really need to be able to simplify is going to happen next week. So we'll do our lesson today. We've got some practice. We're still not even going to get into Delta Math because of the Chromebook situation. But I think at the end, if we have some time, I've got some whiteboards and we might do some practice on some whiteboards and kind of move around and stuff. So look forward to that. But let's go to page 4. Okay? We got 3 pages of notes today. I sometimes skip around. I don't always do every problem. Blue packet, page 4. Pencils out. I also think I might do the middle page last. I was kind of looking at the way it was set up, and I kind of might skip around. But for the beginning, typically when you come in, you will usually have a warm-up. It's almost, if you do have one, it's in the notes packet. And when you get in here, when we don't have to go take full pictures, that's what I want you to start on. So there's 2 problems right there. The instructions are to simplify, so that's what we did last class. And I want you guys to go through and work 1 and 2 and then stop right there. Talk to you guys kind of on my first day of school spiel. I'm really big on checking your work, especially in math. There's lots of rooms for mistakes. Y'all saw I made 2 on our homework, okay? So we want to always show our work, show our steps, so that way I can see what's going on here. On number 1, you had to distribute. You had to distribute a negative. Look here. This was on almost all the distributing problems last time. A negative times a negative is a positive. That's huge. It's a very common mistake that people make. So I'm going to make you practice it a lot. So that way if you accidentally make the mistake, next time you'll think twice about it. So we had to just distribute in the negative 7. We had a 2x that dropped down that we did not distribute to. So it was not in parentheses. However, I have to do one more check before I put a box and make sure I combine anything there. So my answer, my simplified expression was negative 5x plus 56. Y'all did really good on that one. I walked around and most of y'all had that one done already. The second one I had a couple more questions about. But I actually, in my opinion, I think the second one is a little bit less work because do you have to distribute here? No, I think y'all might see this and be like, whoa, that's a lot. And it kind of looks overwhelming. But what I do is I just focus on where are my like terms. You can have 2, 3, 4. or none to combine. So I just kind of read my expression, and the first thing I do is I start grouping them. So I see a 30A. No A, no A. Oh, there's an A, and I'm going to underline with the sign. You've got to look at that sign. The sign is the name tag. It's telling you if the coefficient is positive or negative. If you miss the fact that that 13 is negative, you're going to make a mistake. Are there any other A's in there? Any other A's in here? No. So what happens when I combine those coefficients? 30 plus negative 13 is what? 17. And then what makes them alike? They both have an A. Another thing, I know I've told some of y'all this in working with you, if it helps, excuse me, if it helps with a problem like this, just mark those off. You're done. You combined those, ignore them, okay? Sometimes people like to do that to make it look less busy. So I'm going to go to my next thing, my plain numbers, constants. 3 is a constant. 2b is not, because it has a b. Is 7 a constant? Yeah, it's a plain number, and it's positive. What is positive 3 plus 7? So I'm going to put plus 10. You have to have a sign in between. The sign tells you what type of number it is, name tag. The 10 is positive, so we put a plus. Those are my only 2 constants. Mark them off. Last guy, B. I'm going to put boxes around the B's with the signs. 2B, positive 2B, plus 7B is 9B. So plus 9B. You can swap the order of those. I usually kind of go left to right, but it would still be right if you said 9B plus 17A plus 10. Or if you want to put the 10 in the front. Whatever works for you. But sometimes I feel like y'all are seeing those ones with like multiple sets of like terms. Doesn't necessarily mean it's harder just because it's longer. Okay? All you got to do is 3 additions and you were done there. So simplifying is very important because when we get into our solving, simplifying is going to be our step 1. And then over the next 2 days, when we get into more advanced equations, you're going to have to do these skills before you even start solving. Okay? So remember, math builds. Every day, we're going to make a little bit more advanced, okay? But we got a lot of checkpoints in between. So here's what we're starting on today. Is we're going to solve equations, and then we're going to solve inequalities, okay? I talked about vocabulary. What does it mean to be an equation? What does it have to have in it? Equal. So I would underline right here, equations have equal signs. So that means you are getting a numerical number. X equals this. All of our answers are going to look like that. They may put a different variable. I don't know. Sometimes we do. There might be like a P in there or a K. But you're going to get X equals this. Variable equals a number. Okay? So equations have equals. They're different than expressions. All right? And when we solve them, what we want to do is we want to get that variable by itself. We want to isolate. Have you used the word isolate before? Yeah? Okay? You want to move stuff around. And to move stuff around from side to side on the equal sign, we have to use inverse operations. What is an inverse operation? You basically do the opposite. So if we look at number 1, we're solving for x. We have x minus 7 equals 12, and I want to isolate that x. Well, I got to move that 7. The opposite of subtracting a 7 is what? What's the opposite of subtracting a 7? Adding a 7. So in equations with equal signs, did y'all ever draw a line down like that in middle school? And you're going to take that 7 away by its inverse, which is going to be adding 7 right here. And that's going to make that move. Because what's negative 7 plus 7?
It's just 0.
It's 0. You're zeroing that out. That's what an inverse does. But this is an equation, so we got to keep balance. So if I do a plus 7 over here, what I got to do over here? I got a plus 7 on both sides. So that's a big deal, you guys. You always have to do the inverse operation to both sides. And then, here's a little check on what we just did. 12 and 7 are like terms, aren't they? Aren't they? They're 2 plain numbers. What are our plain numbers called? Constants. 2 constants. We add them up. 12 plus 7 is 19. And so here's what I was talking about. You're going to get a numerical solution. X is equal to 19. What does that mean? What does that solution mean? You might know? Anyone take a guess? What?
Actually,
Never mind.
Wait, so you're saying what is it?
What is it? What am I doing? When I get that x equals 19, what does it mean? If you look at the original, what does it mean? You're solving for what?
X.
You're solving for x. See?
It means 19 minus 7 equals 12.
Exactly. When you find the solution, your whole question is, hey, what number is going to make this true from the start? And so you can go back. Here's what's nice about solving equations versus yesterday or whatever day we had. When you get a solution, I want y'all to know that. This is our solution. When you get a solution to an equation has a equal sign. You can always check it. You can do what Zane did. You can throw that back in and make sure 19 minus 7, type in your calculator if you need to, oh, that does equal 12. So you know you did it right. So what I like about equations is you can always go back and you can make sure, and you can catch when you make those like silly math mistakes here and there. Okay? You guys try number 2. Pretty similar. It's a 1 step. These are 1 steps, so this is like baby steps. We're going to get into multi-steps. So number 2 is fairly similar. We're getting x by itself. We got to take something away. And we need to know how. Draw our line. It's an equation. Okay, step 1. What do we do first? Minus 7, very good. It's important that you do it on both sides. That's going to zero out there. We have x all by itself, and that's the goal, is to get x by itself, nothing in front of it. What is the coefficient of x?
5.
Oh, no. That's the solution to x. What is the coefficient, the number in front of x right now?
1.
A 1. You don't have to write a 1, but that's how you know when you're done. Like just plain x, 1x. Now, where'd you get the 5?
Minus 7 from 12.
And you get x equals 5. There's our solution. X equals 5. Plug it back in. 5 plus 7 does equal 12. Okay? So that's how we move things that are being added and subtracted as our inverse operations. Remember, inverse is opposite. Look at number 3. 7x equals 21. What is happening? What is the operation right here? Okay, so it's there's not 2 terms. There's only 1 term. I think that's what you mean by simplify. And you're right. But my question is, what is happening between 7 and x? Not how to undo it, but when you have a number next to a variable, what does that mean when they just put them side by side?
Multiply.
That they're multiplying, okay? That's a big idea. So whenever you see a coefficient in front of a variable, I want you to know these guys are being multiplied because they're squished next together. And then how do we undo multiplication? We divide. And what we do to one side, we have to do to the other side. And so 7 divided by 7 is what? 7 hold on, you're 1 step ahead. 1. And so I'm left with 1x, which is my goal. You don't have to write the 1. You can kind of show that it's simplifying down like that, like I did. I kind of drew my line through it. But that anything divided by itself is 1. On the flip side, 21 divided by 7 is 3. Do y'all know how to type a fraction in the calculator?
Yeah.
How do you do it?
You do second.
Not second, close though.
Alpha length.
Alpha, okay, so alpha and the button right next to it. I don't know if all of my calculators do that.
It doesn't do that.
Yeah, so here's the way that we do it here. Some of these, I don't know why some do and some don't. Alpha, green button, and then if you go up to the very top button up here that says y equals, I'm pointing to it. It's one more step, but alpha, y equals, and press enter. That should work no matter what type of calculator you have. Because at Wakeland, I don't know if I talked about this, but not all the math classes have these newer calculators. And so only the very new ones have alpha links. So I want y'all to get in the habit of alpha, y equals, enter. This makes a fraction bar, but that's what division is. Division is a fraction. So I always, if I'm dividing something, I normally just put it in my calculator as a division, 21 over 7. If it simplifies, if it divides evenly, I get a whole number. But there's going to be some times that we get fractional answers and we want to reduce those. Is it okay to get a fraction as a solution? even though it looks kind of yucky. It's okay, and that could work. That could be a solution there, okay? So that's how we undo multiplication. What's happening on number 4? What's happening to x?
1 divided by 7.
It's being multiplied by 1, 7. X is being divided by 7. Okay? You could see it like this. I actually like that you bring that up. You could see a problem written like this, or they could also write it like this. 1/7 x equals 10. It kind of just depends. Okay? When the x is on the top, I think that's a little bit easier because to me, I'm like, oh, x is being divided. How do we undo division? Multiplication. So we're going to multiply both sides by 7. And I'm going to use parentheses here to show my multiplication.
When you guys see parentheses, what should you think?
Multiply.
That's why we're putting those parentheses.
Yeah, the days of representing multiplication as an x are over. Okay? We don't do x as multiplication because that's kind of confusing, right? Almost all of our problems are going to have an x in them. So when we multiply, use parentheses. Do y'all see how I did divide right here? Did I do the little divide sign? Like this divide sign? No, we don't like that either. We're done with that, and we're done with this. Okay, x is a variable here. So I set up this division as a fraction, and that's how I typed it in my calculator. I want you guys to get in the habit of that. We're done with divide, we're done with x for multiply. So what happens here when I multiply 7 times x over 7? It's not 7x. 7 divided by 7. We just did it over here. 7 divided by 7 is 1.
7 divided by, or 7 times 1.
Oh, yes. So it basically ends up becoming 7 times 1/7, which it's going to, and that should happen. You can always check in your calculator, but that should happen. That's why we did the times 7, to undo it. It undoes it by making it become a 1, and we bring down the x. On the other side, 10 times 7 is 70, and that's our solution right there. Okay, so these were just baby steps. To be honest, you're not going to see a question that's just a one-stepper like that on the test. It's all going to be multi-steps. So let's get into two-step equations. What makes multi-step equations, I think, a little bit trickier is you have to make sure you're doing the correct order. So when we simplify, we follow PEMDAS. I know I said that last class. We took care of parentheses, then we did, which is multiplication, then we did adding and subtracting. When we solve, we do it backwards. Simplify to solve. SADMEP. Okay? You don't have to memorize that, just kind of hear what I'm saying. When you solve, you're actually doing the complete opposite. So, your goal is going to be to add or subtract things over first, and then undo them by multiplication or division. So if you think PEMDAS backwards, that might help you. What I usually say is just, if I'm looking for x, I work furthest from x, closest to x. So I don't know what works for you. You pick one way. So if I look at number 5, I have 9x minus 7. On that side, the 9 is right next to x. So that tells me, hey, that has to be like the last thing that I do. And then the 7 is a little bit further from the x. Y'all see visually how that's happening? Yeah? Okay, so my first step in this is to do what? We already said the 7's further, so we got to move it. And we move subtraction by adding. And what we do to one side, we have to do to the other side. Okay? So I'm going to draw a little line right here. This is going to zero out. What's coming down on the left-hand side? 9x. Okay, so this is where it gets a little bit different. We don't have x by itself already.
Wait, don't you not have, since you had it, Jay's, oh, never mind.
What's negative 7 plus 7?
Oh, that's
0.
Oh, that's what it was.
Ooh, we're throwing out this on problem number 1. 0 is a number, guys. We're not going to freak out if we see a 0. We're okay. 0 is a number. Okay, so I got the thing that was furthest. I did my addition or subtraction first. So addition and subtraction has to be first, either or. And then I need to undo my multiplication or division. So what's happening to the x? I talked about this. When a number's next to a variable, it means they are multiplying. How do you undo multiplication? Division. So on both sides, we're going to divide by 9. So I'm going to get x, because 9 over 9 is 1. So that's going to leave me with 1x. I'm going to go to my calculator, and I'm going to type alpha y equals practice this. Practice getting alpha y equals. I promise you're going to want to do this every time to simplify fractions. And you are dividing 0 by 9. 0 is a number. It's actually a pretty easy number to work with. What is 0 divided by 9? 0. So what's the solution to this problem?
0.
X equals 0. Okay? So that means 0 is the only number that's going to give us a balanced equation. Getting 0 as an answer seems kind of weird, but it happens. It can happen. Okay?
Real quick, Ms. Brett, just
Yes.
real quick before you talk. I walked around just kind of checking, guys. Organization is big. Keeping it lined up, just like Ms. McCartney did, that is huge. If you just put a 7 off to the side somewhere and put a plus, you're going to get confused. Keep it lined up and keep it organized. It'll make your life 100 times easier. Okay, we want to make your life easier. Keep it lined up. Okay?
Yeah, we do. All right, I want y'all to try 7 and 8. 7 and 8. I'm going to circle them right here. We'll do a fraction one together. 7 and 8, I want you guys to try right now. Okay? Follow the work. Keep it organized. Beauty of a small class and 2 teachers. Here are the 2 I asked you to do. Some of you guys are jumping to the fractions. Some of y'all are already rocking it. But if the fractions are a little overwhelming, I'm going to go through those as well. These are our 2 steps. Is this familiar?
Yeah.
We have a little bit of deja vu here. Great. Make sure, again, it's the order. It's the order that matters. Add, subtract, then multiply or divide first. Okay? When you're solving equations, what do equations have? A equal sign. And your answer is called the solution. Very good. So we got solution x equals 5. Careful here with your signs. Signs are very tricky there in algebra. So we want to be careful with that. So we end up with a negative over a negative. Again, I put it in alpha y equals, and it's going to take care of that simplification for you. And it simplifies to a nice pretty number here. Y'all, how I am writing these problems, this is what I want you to do on them on your test. Step by step. I know it's kind of a small space, and that's my bad. That's what happens when I work on stuff in the summer. I forget. But I do want to see what you are doing. I need to see what you're doing to both sides. I need to see what you're doing to get your answer. I know some of y'all can divide negative 20 by 4 in your head, but I want you to show me so that way if you do make a silly mistake, I can see right idea, tiny mistake. Tiny mistake's going to be like -2. Big mistake, because I don't know what you're doing, that's going to be a lot more points. Okay? I think someone might have asked, how do you check? Did you ask that? How you check your answer? So let's talk about 7. So if we get the solution x equals 5, and I said equations are great because you can check. I can take that solution and I can plug it in for what it's equal to. 5 and x are the same thing. So if I go to the original equation, where I see an x, I can put a 5, right? So let's do that. Let's get our calculator. Now we're going to type. We can't type a full equation in calculator. We can only do one side at a time. So here I go. It says in the calculator that it's -4. What am I subbing in for x? 5. So I'm going to open up a parentheses. The parentheses are right above the 8. I'm going to sub in a 5, and I'm going to close it out. Okay, so look at what I just did. If you can't see parentheses, I would try this. This is actually a lesson we're going to do in a few weeks. So free teach. That lesson will be easy if you know how to do this. So sub in the solution. Now, that's not all the left-hand side says, is it? So plus 5 is what's next. So I replaced. Is there an x in there anymore? Is there an x on my calculator? No, because I found it. I found that it was 5. When I press enter, I will get it right if what number pops up? -15. If you press enter and it's not the other side, what does that mean? It's wrong. Go back. Try again. Okay? So this is the beauty of being able to have an equation is you can plug it in. And that's how you do that. You put it in your calculator, left side, right side. The right side we didn't have to type in because there was no x there. Let's talk about the fractions. 6 and 10. Okay? We're still following our same order here. So I have x over 4 plus 2. I'm going to put a star by this problem. Okay? When I put a star by something, I don't write the star test. I wish I did. My students would do pretty well because I'd make sure they were prepared. But I write y'all's test. So if I put a star on it and you're looking back through your notes before test day, that's always something that I'm saying, hey, catch your attention and make sure you know how to do this. I think this is a question that could use a star, okay? So let's talk about what's happening. X is being what by 4? Divided. And then we're doing a what? Adding 2. So when we follow our reverse order of operations, or we work furthest to closest, what's the first step we need to move? -2 on both sides. -2, -2. Some of y'all were working ahead and did y'all get that set first? Okay. Takes it out. Then we have x over 4 equals 6 minus 2 is 4. Okay, we kind of already did a problem like this right up here on, I don't know what number it is because I wrote over it, but right above it, 2 above it, 1 above it, I don't know. X is being divided by 4. How do we undo division? Multiplication. So we're going to take both sides and multiply by 4. Undo. 4 times 4 is 16. And that's our solution. Anybody work ahead already get that? Some of y'all got it. Very good. Okay. Order matters. It's the same order what we were doing. It's just that in the other problems, X was being multiplied. This one, it was being divided. It's most common to see multiplication, but it can be division. Now, let's look at number 10. This is another one I'd put a star by. It's a little different. Let's talk about what's different. There's a fraction bar in there, isn't there? Okay. But the numerator of our fraction is what? X plus 9. Our other numerator was just x by itself. So that means, because x plus 9 is up together in the top, that means that we have to undo that 9. We can't undo it step 1 because there's that 3 on the bottom. So do y'all see the difference here? We're going to have a different order here because of the fact that the plus 9 is up at the top. So right now, 9 is plus 9 is the closest thing to x. What's the furthest thing from x right now?
3.
The 3. And what is the 3 doing?
Dividing.
We undo division.
Multiply.
Multiplication. So we're actually kind of doing something different here, and that's because of how it's set up. If you want to put parentheses around the top, that might be helpful.
That'd be 27.
So we're multiplying by 3. Where'd you get 27? Oh, hello. Multiplying by 3. And so this is going to give us x plus 9. 8 times 3 is 24.
Oh, I did 9.
Oh, I see what you're saying. So this is a tricky problem, and I get that. But when you take out the 3, it did not change my x plus 9. I kind of put it in parentheses so it'll be there by itself. And then now, what do I have to get away from x?
The 9.
9. But it's plus 9. So how do we get it away from x? We subtract 9. So depending on how it's set up, and this is a big idea, but depending on how it's set up, you got to think about what moves first. And 24 minus 9 is 15. We'll practice that. And there's a kind of another way you could think of it too. I might go over that in a minute. Okay? I'm going to jump y'all try 9. Y'all try 9 real quick. Yes, I can. Try 9, and then we're actually going to go to page 6. We're coming back to 5. I'm not going to do all the problems on 5, but we'll come back to it. But we've also in this unit, I don't know if you've looked at Canvas or looked at the title, but we called it solving equations and solving inequalities. Okay, so I want to talk about some vocab here. The good news is there is not a lot new. Okay, very, very similar. That's why we kind of clumped them together. We're on page 6. You should see some number lines on here. But there is a difference between an equation and an inequality. Okay, not page 6, page 6. You went one too many. There you go. Page 6. So every day, the next couple days, we're going to be in equation land first, and then we're going to jump to inequalities. You can kind of look at your paper, but do you know what an inequality is? An equation has an equals, and an inequality can have 4 different things. What are those things? They're up there. Y'all know what those are called? Don't say alligators. We're in high school now. Less than? That's one of them.
Less than,
Greater than?
Equal to.
Greater than or equal to? Less than or equal to. So there's 4, but they're kind of close there. So those are inequalities. So when we find our solution to an equation, what does an equation have? Equals. We get x equals 5. That means 5 is the only number that works. But if I get a solution that's x is greater than 5, what are some numbers greater than 5? 6. Is that it? 8, 11, 12. So there's a lot more answers because you're kind of talking about a range. All the numbers greater than, all the numbers less than. So when we have inequalities, it's not necessarily that there's one thing that works. There's going to be an area of things, a range of things. So that's why we have our number line, is we're going to say it's this guy and everything after it, or it's this guy and everything before it. So a little bit different in how you write your answer. The good news is the solving, there's nothing different. Okay? It's still your same steps. You're isolating x, you're getting it by itself, but instead of x equals, you will have a symbol in there. I'm actually going to do number 2 first. Yeah, welcome to my class. I never go in order. I type it out in order, and then when I teach it, I'm like, I should have done it this way. So we're going to do number 2 first. Okay? We got a variable y. Cool. Change the letter. We're solving for it. 3y minus 7. What symbol is that? Less than. Let's write that out so we can practice with that. What does less than start with? What letter? Anyone make an L? Make an L. Turn it sideways. There's your less than sign. There's your less than. If you forget, I'm going to say that. Sideways L. L, sideways. Ooh, matches. That's got to be a less than. Okay? So, keep it the same. Just keep doing what we're doing. What do we need to move to get y by itself?
7.
Need to move a 7. How do we move a 7?
Add 7.
Add it. Braden, you with me?
Yep.
Add 7 to both sides. So we get 3y. Drop down my less than. 23 plus 7 is 30. So y by itself?
No.
Not yet. We're close. How do we undo the 3?
Divided by
Divide it by 3. Now, there is one thing we have to be careful about when it comes to inequalities. It's not going to happen on this problem, but it will. What kind of 3 did I divide by? Positive. Positive. That's important. If it's positive, nothing changes. We'll get to what happens when it's negative. So this is going to become y. My less than sign stays because the 3 was positive. What's 30 divided by 3 simplified to? Fraction. You probably do in your head, but I'm just going to be consistent. 10. So my solution set, I'm going to box this, is y is less than 10. But we kind of had this conversation. There's a lot of numbers less than 10, right? Is 10 a solution? Is 10 less than 10? No. Is 10 less than or equal to 10?
Yes.
Good to know. Okay, so I need to know that it's 10 and everything smaller than that. So when we put this on the number line, let's put the number, let's put a little mark right here, and let's put 10. I don't need you to put a bunch of numbers. We'll just put 10 right there. We'll do 1 to the right. What number is going to be to the right? Greater than 10. 11. What's going to be to the left? Left of 10, I'm sorry.
9.
Left of 10 is going to be 9. So that's all you need to do. I don't need a whole lot of numbers. Put your number that goes with your solution in there. But then I have to represent, okay, does 10 actually count as a solution or not? And that's what I was asking over here. I said, is 10 less than 10 work? And y'all said no, because 10 is not less than 10. So if 10 doesn't actually work, if you just have a less than, you put it, well, correct. But it's not a solution to this, because this doesn't have an equal to, right? So if it doesn't have an equal to, above this number, you're going to put an open circle. So y'all see right here? Where we said if you got a less than or a greater than, you put an open circle. That means that number is not in the solution set. It's just your starting point. So we can't actually fill it in because it doesn't actually work. And which way represents the numbers less than 10? Left or right?
Left.
Less than, go to the left. Okay? Numbers less than 10 goes this way. If you put your variable on the left, only if you put it on the left. Do you see how this sign is pointing? When I'm looking, do y'all see how it's pointing?
Yeah.
Do you see how this arrow is pointing? The same way. So I always like to put my variable on the left with inequalities.
It
Okay?
only works if the variable's on the left.
Only works if the variable's
But
on the
it's a
left.
great trick.
Yes.
Oh, I always like to have my variable
Yeah.
on the left.
When we have to move stuff next class, I will tell you in inequalities, get your variable on the left. It's easier. Okay, let's look at 13 real quick. We're going to do this one together, but I want y'all to walk me through. 13 minus 4x, what symbol is that? In the original. Less than. It's a sideways L. So, are we going to have an open or closed circle? You can kind of already tell. We're going to be open because we don't have that line under there. Okay? All right, we got to get x by itself. What moves first?
13.
Why?
You have the front, left to right.
Okay, it's the furthest thing from x. We have to move our add or subtract first. How do we move 13? Drop it down. How? How do we drop it down? How do you make that become 0? Positive 13. We have to subtract it. Even though it's in a different spot than the other guys, that's okay. And I will tell you, the STAR test loves to put stuff in different spots. It's kind of annoying. Okay? All right, so we've got what drops down on the left-hand side? Negative. This is kind of tricky. Don't lose that. Negative 4x is less than 25 minus 13 is 12. Okay? Now we need to get rid of that negative 4. How? Do what?
Divided by negative 4.
Divide both sides by negative 4. All right, what kind of 4 are we dividing by? A negative. Does anybody remember with an inequality what happens if you multiply or divide by a negative number?
You switch it.
You flip the sign. This is the one special thing that inequalities have. And it only has to do with negatives. Remember when I was saying 3 is positive, okay, we don't change anything? This 4 is negative. So we have to flip our inequality sign. Why? Because we divided by a negative. So what that means is our solution looks like this. X, I flip my less than to a greater than because of the flip. Okay? And then 12 divided by negative 4 is negative 3. You only do that when you have a negative on the bottom. It doesn't matter what this guy is over here. We don't care about that. It's the one that I circled. And it's a tricky rule, but you got to remember it. If you divide or multiply, we don't typically multiply with those, but most of the time it's dividing. If there's a negative, we got to flip. So let's set up our number line. This one's kind of tricky because it's negatives here. Negative 3. What's the number that's just one bigger than negative 3? 2. Smaller? Negative 4. Again, we're not equal to, so we put an open circle. Greater than, bigger numbers go to the right. Can you do our trick here? We got x on the left. Can we do our trick there? Yes? Yes? Okay. All right, you guys think you can try 3? Challenge problem? You know what to do first? I'll get you started on step 1. When we got a number in front of parentheses, what's our thought? Distribute. We practiced this last time. Negative 2 times t is? Negative 2t. Give your t a little curly so it doesn't look like a plus sign. Negative 2 times negative 9 is? Negative times a negative is a positive. Greater than or equal to negative 58. I think you can take it from here. It's kind of a precursor to what we're doing next class. We're going to bring back distributing next class. But once you get it like this, you can go. Okay? All right, I'm going to start kind of working this one here. Guys, I want you to kind of keep in mind with inequalities, it's the same step as equals. You can draw your line. You move stuff by doing inverse operations. Okay? The only thing that you have to watch out for with an inequality is if you multiply or divide by a what? By a what? Negative. All right here. What am I dividing by? Negative. And make sure when you do this last step of dividing, did I write a t down here? No, you're just dividing by the number. So this is a negative. I always write a little to the side. I always write flip. So it reminds me when I get my solution. So t is, this is going to flip, and it's going to be a
Greater than less. Greater than or equal to.
Oh, it's a greater than or equal to right now. So it flips and it's going to be a less than or equal to. Negative 76 divided by negative 2 is positive 38. Positive 38. Negatives, when you multiply or divide two negatives, they become positives. When you add two negatives, they become a bigger negative. So this is your solution set, but now we got to put it on the number line. You're going to have to put solutions on the number line here. So in the middle, we got 38. What do we have to the right? 39. What do we have to the left? 37. What kind of circle am I going to put above 38? Why is it closed?
Because it's equal to.
Because it's equal to. 38 is in the solution set because it's equal to. Listen to me here. Did it take extra ink to draw that equal to under the sign?
A little.
Extra ink, a little bit. So do I need to take a little bit extra ink and color it in?
Yes.
Yes, I do. Okay, that's a big idea. So I want to go less than, so I go to the left. Okay? All right, I think I'm going to wait on page 5. We're not going to do all those, but I do want to talk about them, and I think I'm going to wait till next time because I want to do some practice real quick. So you can go ahead if you want to put your notes up, keep your calculator.